For over a century, electricity has powered human progress. Today, we're entering a new era. An era where power systems are no longer static. They are dynamic, distributed, and deeply interconnected. Renewables are scaling at unprecedented levels. Data centers are becoming gigawatt-scale loads, and the power grid is becoming one of the most complex ecosystems ever built. At ETAP, we have been laying the foundation to solve this problem for nearly 4 decades. And today, I'm proud to introduce ETAP 2026, our AI-augmented digital twin platform to design, plan, operate, optimize, and automate electrical power systems. This is not just a software upgrade. This is a fundamental shift to continuous energy intelligence. ETAP 2026 represents a step change in how we design, operate, and optimize power systems. It's built on 9 pillars of innovation, each addressing a critical dimension of the modern electrical ecosystem and together redefining what is possible. From AI-augmented intelligence that accelerates decision-making to a modern intuitive user experience that removes complexity from engineering workflows. From a secure, cloud-native, and cyber-resilient foundation to open data exchange that connects systems, tools, stakeholders across the ecosystem. From advanced safety and protection to intelligent asset management that extends performance and reliability. From deeper, more precise dynamics and transient analysis to seamless integration of renewables and grid compliance in an increasingly complex energy landscape. And ultimately, automation and real-time operations where insight turn into actions. But behind each of these innovations is something even more essential: trusted data. At the core of ETAP 2026 is the ETAP Engineering Library, one of the most comprehensive collections of verified and validated equipment models in the industry. This release expands that foundation dramatically with over 23,000 new models, including more than 17,500 protective devices from leading manufacturers such as ABB, Eaton, Siemens, Schneider Electric, and Rockwell Automation. Over 900 cable models, and more than 5,000 solar panel models from leading global manufacturers. This is what gives ETAP its edge. Not just simulation, but engineering-grade physics-based accuracy at scale. Together, these 9 pillars converge into a single unified capability, from design to operation, and of course, optimization. An AI-augmented physics-based digital twin of the electrical system, delivering continuous energy intelligence.
Hi everyone, my name is John Francis. I'm going to walk you through these 9 pillars of innovation in more detail, highlighting the key features in this release. Let's start with a question on everyone's mind. What does artificial intelligence actually mean for electrical engineering? Because here is the truth. In our industry, intelligence without trust is a liability. Engineering AI must be held to a higher standard. So let me be clear about what AI does not mean. It does not mean sending your confidential network data to a public AI cloud. It does not mean trusting a general purpose model to reason about protection, coordination, fault currents, or grid stability. This is not what we are building towards. With ETAP 2024, we delivered the world's first private electric AI copilot, purpose-built for power system engineering. And now, in ETAP 2026, we are scaling that innovation across every stage of the power system lifecycle with the latest version of our AI copilot. You type a question in plain language, instantly search across your entire project, study results, equipment data, protection settings, and get a meaningful answer. No filter, no SQL, just ask. You can create and modify one-line diagrams using natural language chat commands. You can ask Copilot to analyze a study report and explain what it found. Have it generate a customized PDF report in seconds. It converses in multiple languages, and it draws its guidance directly from the ETAP knowledge base, delivering accurate, engineering-grade answers every time. And the new AI autocomplete, embedded directly in the one-line diagram, suggests new elements and connections based on the context of your existing network. Local intelligence, private, instant, early deployments of the ETAP Electric Copilot and AI-assisted autocomplete have demonstrated productivity gains of up to 20 to 30%, significantly reducing time spent on modeling, engineering analysis, and reporting. And this is just the beginning. It is the beginning of what intelligent engineering and operation workflows can become. In our next phase, the ETAP Electric Copilot will evolve from a responsive assistant into a proactive engineering and operations partner. It will not only answer questions, it will anticipate needs. It will help identify inconsistencies, recommend optimizations, and assist engineers in validating designs and operational decision-making long before issues reach the field. Because the future of our industry will not be defined by engineers who use AI, or by AI that replaces engineers, it will be defined by engineers and AI working as one. Designing, operating, and protecting the system the world depends on. That is the future we are building, and it starts here. A powerful analysis engine is only as effective as the experience that puts it in your hands. And our customers have always made it clear. They need less friction, faster workflows, and more intuitive control. This is the approach we have always taken with ETAP, and with this new release, we are redefining how engineers interact with power systems. We are introducing 3D network visualization, moving beyond the limitations of traditional single-line diagram. Engineers can now explore their networks in 3 dimensions through actual connectivity, interacting with data and simulation results in a far more intuitive and immersive way. And with 3D network visualization, engineers can instantly understand connectivity and identify isolation points that would otherwise remain hidden in traditional nested views. This is the shift from static representation to true system understanding, from how the system was drawn to how the system actually behaves and connects. Faster, cleaner, more intuitive, from the first interaction to the final report. And we are also introducing a new Network Manager, a powerful tabular interface that allows engineers to visualize, filter, and edit system data at scale, dramatically accelerating data management and troubleshooting across the most complex projects. Consider a major offshore wind developer, engineering a 600 megawatt offshore wind farm. Their model includes thousands of elements, including cables, offshore substations, reactive compensation systems, wind turbines, and their associated collection system. Today, engineers can spend up to 40% of their time on data-related tasks, manually entering data, cross-checking properties across spreadsheets and diagrams, and identifying inconsistencies during critical studies. With ETAP 2026, we are making the status quo change. The Network Manager provides a synchronized matrix-style view of the entire system data at a glance. You can review, filter, find, and edit essential data directly in a tabular format, with full alignment to the one-line diagram. This includes engineering or non-engineering properties, whether in base or revision. Additional enhancements to revisions in this release include the ability to modify the one-line diagram, not just the data. ETAP 26 just set the new expectations of efficiency for working with large-scale projects with numerous scenarios. What previously required days of data validation can now be completed in hours. ETAP has always been deployed at the heart of critical infrastructure, power plants, substations, data centers, nuclear facilities, the security of our software is not a feature, it's a responsibility. In ETAP 2026, we have fundamentally re-architected the ETAP License Manager, introducing over 30 cybersecurity enhancements designed for modern enterprise environments. At the foundation, we have hardened the platform against common vulnerabilities and exposures, with enhanced reliability using an automated license key exchange and improved compatibility across enterprise licensing systems. We are also introducing cloud licensing, a unified framework that enables company-level configuration, centralized user and profile management, administrator controls, and user assignment. Beyond licensing, the entire platform has been strengthened. ETAP 2026 is built on an ISO 27001 certified foundation, with a robust, secure development lifecycle, a defense-in-depth architecture, a hardened encryption across passwords, messaging, memory, and data in transit. Now consider a multinational power engineering consulting firm, with teams distributed across regions working on the same project in parallel, or a hyperscale data center operator, designing gigawatt-scale campuses where software must be securely deployed across teams, validated by third-party auditors, and protected against supply chain risks. With ETAP 2026, this becomes seamless. The License Manager, fully aligned with CVE framework, enables centralized and secure license governance across offices, teams, and projects. No hardware logistics, no delays, no compromises on security. This is enterprise-scale control with enterprise-grade protection. ETAP 2026 is built for the enterprise and secured for it. No discipline in electrical engineering carries higher stakes than safety, and it remains at the core of everything we do. ETAP 2026 advances safety engineering with full compliance with the latest ANSI and IEC standards, analyzing worst-case scenarios across all fault types, using the latest short-circuit engine, because the reality is uncompromising. An arc flash can reach 35,000 degrees Fahrenheit, nearly 4 times the surface temperature of the sun. In that moment, outcomes depend on one thing. Was the system designed correctly to the latest standard? With ETAP 2026, our customers can be assured that their designs comply with safety standards. For example, this release adds support for NFPA 70E 2027, CSA Z462 2024, EN 50110-1 2024. We've also enhanced the performance and fidelity of safety engineering. Faster arc flash and arc fault calculations engines for large-scale studies. Improved differential relay modeling for complex coordination. Complete arc flash settings import and export, enabling seamless standardization across sites. As AI factories and battery energy storage systems scale, DC arc flash is becoming a critical challenge. Traditional methods rely on steady-state assumptions, often missing the true behavior of fast-evolving DC faults. ETAP 2026 introduces transient DC arc flash analysis, an automatic source protective device clearing time calculation, and the 3D MHD DC arc flash analysis method. This moves us from an approximation to true physics-based modeling of arc behavior over time. Consider a utility-scale solar and battery storage plant. In a DC fault, current rises and decays rapidly. Protection response depends on this transient behavior. With traditional methods, instant energy can be miscalculated, PPE may be over or underspecified, and protection settings may not reflect real conditions. With ETAP 2026, transient arc behavior is accurately modeled. Protective device response is dynamically calculated. Incident energy is determined with far greater precision. The result? PPE selection is more accurate, over-design of PPE is reduced, and there is greater confidence in worker safety. We have also introduced transient capacitor energy discharge analysis to continue to push forward in the world of safety and to ensure people are protected. ETAP 26 includes the new NFPA 70E 2027 requirements, reporting lung and hearing protection boundaries, discharge current and voltage plots to show safe discharge limits. Another solution that was also high in demand from our renewable customers is also addressed in ETAP 26, which is the finite element method for underground raceway systems. And since we were focused on adding this new methodology, we also updated the user interface entirely with a sleek and modern D2D graphic user interface. FEM allows for user-defined configurations for cable installations such as trefoil, flat, cradled, and many others. Calculate and report temperatures at all cable layers at any location within the UGS presentation through PDF, Word, Excel, as well as contour and heat map plots. Lastly, with UGS, we also added cable cyclic rating calculations per IEC 60853. Continuing with safety in the form of protection, STAR-Z is enhanced with stepped event analysis. For multi-stage short circuit and protection and coordination evaluation, which is essential in looped and meshed power systems. With this tool, you can simulate all protective devices supported in STAR and STAR-Z, while dynamically updating short circuit currents and relay operation as the system configurations change. It automatically evaluates coordination between current-based protective devices and provides clear notifications when fault isolation or re-energization succeeds or fails during reclosing. Stepped event analysis also supports both transient and permanent fault simulations, giving engineers a powerful way to validate protection performance and system response under real operating conditions, all in one unified workflow. STAR TCC now enables comparison of original and shifted curves, real-world timing adjustments, and an even clearer visualization of coordination across conditions, as well as a new consolidated Excel-based device settings report. With ETAP 2026, safety and protection can be engineered with greater accuracy, speed, and confidence than ever before. Great engineering doesn't end at commissioning. An electrical system must be continuously maintained, tracked, and validated throughout its entire operational life. And the stakes have changed. For example, in the US, the National Fire Protection Association, NFPA 70B standard, has evolved from a recommended practice to a prescriptive standard. Facilities are no longer encouraged to maintain records. They are required to. Until now, this has been a major gap. In the past, maintenance records were scattered across many different documents. Spreadsheets, paper binders, separate asset systems, completely disconnected from the engineering model used for arc flash protection and system studies. ETAP 2026 closes the gap. With record and track maintenance intervals, maintenance is no longer external to the system. It becomes a part of the digital twin. Every asset breaker, transfer switch, and relay now carries maintenance intervals, last tested dates, condition indicators, and alert thresholds. And when maintenance is overdue, this doesn't sit in a separate spreadsheet. It is visible directly on the one-line diagram. This changes everything. Engineers and operators can now see in real time which assets are compliant, which assets are at risk, and how that risk impacts the system. ETAP 2026 makes it possible to move beyond static maintenance schedules by combining asset condition, electrical criticality, and system connectivity. This release enables risk-based predictive maintenance. Maintenance is no longer driven by time alone. It is driven by impact on the system. Consider a large industrial manufacturing facility with hundreds of breakers across multiple production lines. In a traditional setup, maintenance schedules are managed in spreadsheets. Compliance is tracked manually, and there is no direct link to system criticality. A breaker feeding a non-critical load and a breaker feeding a critical production line are often treated the same. With ETAP 2026, overdue maintenance is flagged directly on the one-line diagram. The system identifies that a critical feeder breaker is overdue. and shows its impact on upstream and downstream operations. Instead of maintaining everything equally, the team can prioritize the highest risk asset first. This reduces unplanned downtime, compliance risk, and operational blind spots. Other tools manage maintenance as records. ETAP manages maintenance as part of the electrical system itself. This is the difference between tracking assets and understanding their impact on system reliability. Today's power systems behave nothing like the systems of a decade ago. Inverter-based resources, battery storage, distributed generation, these create dynamics, fast transients, frequency instability, and unbalanced conditions that demand a fundamentally more capable simulation engine. ETAP 2026 delivers it. With this version, we also set to remove the fundamental limitations engineers face when relying on traditional motor starting and manufacturer data formats. Conventional workflows often struggle with convergence issues, limited flexibility in handling incomplete manufacturer datasets, and the inability to accurately represent real-world conditions, such as reduced voltage characteristics, saturation effects, or degraded frequency in voltage scenarios. Engineers are frequently forced into manual workarounds, redefining motor models just to accommodate partial curves or missing parameters like torque, current, or power factor, making true system-level analysis slow and inconsistent. MotorPro changes this by enabling immediate parameter impact visibility, supporting incomplete or non-standard manufacturer data without redesign, and allowing fast what-if scenario evaluation for motor starting performance. It also bridges the gap between test data and simulation by enabling direct comparison against measured results, delivering a far more realistic, flexible, and reliable motor starting analysis environment for modern power systems. Ultimately, engineers are able to quickly and accurately estimate and analyze motor parameters based on manufacturer-published data incorporating linear and nonlinear rotor impedance to handle typical or special motor applications. Solve and compare motor starting based on various starting conditions. Import and export acceleration curves. Dynamic visualization of motor torque, current, power factor based on various conditions. Grid code dynamics automatically generates voltage and frequency ride-through events based on your selected grid code, IEEE 2800, PRC 029-1, and others from the ETAP rulebook, sweeps them to produce a compliance report in a fraction of the time it previously required. ETAP grid code integrates with our EMT CoSIM solution, which allows users to use black box EMT models while performing interconnection studies. ETAP grid code supports large load ride-through studies, which is especially useful for AI factories and semiconductor fabrication plants. To conduct these studies in a faster and more scalable manner, we have introduced two powerful capabilities. Network reduction, which simplifies large distribution networks to electrically equivalent representations while preserving full accuracy at boundary buses. And for independent power producers, we developed network aggregation, which aggregates entire PV plant collector systems into equivalent models for dramatically faster interconnection studies. Whether you are working for the grid or the customers assessing time series data, incorporating the dynamic nature of renewable energy is essential. Time series load flow analyzer now delivers comprehensive statistical analysis of systems with renewables and battery energy storage systems. This includes critical result summaries, violation occurrence and duration reporting, and energy consumption and generation details across extended simulation periods. They enable faster, scalable analysis without compromising fidelity. Understanding how a power system responds across the frequency domain has historically required oversimplified linear models or disconnected tools that couldn't handle the scale and nonlinearity of real-world grids. By estimating frequency response directly from time domain simulations, engineers can work with the same large-scale, nonlinear models that they already trust without compromise. The new frequency response estimation tool is a capability that enables generator control system design and tuning, automatically generating Bode plots and calculating gain and phase margins for a complete picture of system stability. As we have discussed some of the challenges and solutions with the energy transition, utilities, industrial operators, and developers have a common question. How much renewable capacity can my network actually absorb safely, while ensuring compliance with these standards? ETAP 2026 answers that question with the most advanced renewable integration toolkit we have ever built. To start with, feeder hosting capacity has been fundamentally enhanced, incorporating a richer, multi-constraint framework that includes harmonic branch current, harmonic bus voltage, short-circuit bus bracing limits, and protective device interruption constraints. This delivers what utilities truly need: a regulation-ready, engineering-grade view of DER capacity. Not just theoretical limits, but what the network can actually support. Consider a utility evaluating a rural feeder with rapidly growing solar PV connections. Traditionally, hosting capacity is assessed primarily on voltage rise, and as a result, the feeder appears capable of accepting additional megawatts. But in reality, harmonic distortion exceeds limits. Fault levels approach breaker interruption ratings, and protection coordination margins are reduced. With ETAP 2026, all of these constraints are evaluated simultaneously in a single unified analysis. The results? The true hosting capacity is identified with precision. The exact limiting constraint is clearly visible, and engineers can determine what upgrades unlock additional capacity. This transforms hosting capacity from a simplified estimate into a multi-constraint decision-grade engineering solution. We have also extended VoltVar optimization to include carbon intelligence. With VoltVar optimization, you can trace the carbon intensity of power from generation to consumption, evaluate emissions impact in real time, and maximize DER utilization without unnecessary curtailment. This is grid optimization with carbon awareness. As the energy transition accelerates, regulators raise the bar on grid transparency. Utilities face growing pressure to extract more value from existing infrastructure without compromising reliability. FERC Order 881 is a signal of that shift, but it's only the beginning. Compliance alone would not be enough. True grid optimization requires a coherent view of thermal limits across the entire transmission path, from overhead conductors to substation buses to transformers. This is why we developed 3 new standards based on solutions: IEEE 738, IEEE 605, IEEE C57.91. Not to simply help our clients meet a regulatory deadline, but to give them the engineering foundation to make smarter capital decisions, defer costly infrastructure investments, and operate the grid closer to its true physical limits with full confidence in system reliability. DesignPro was built to meet the full scope of what modern transmission owners need, not just today, but also in the future as grid conditions and regulatory requirements continue to evolve. Delivered as a web-based platform built on current IEEE standards and continuously updated, DesignPro provides the reliability, adaptability, and integration that utilities need to confidently manage FERC Order 881 and other obligations that make smarter long-term infrastructure decisions. ETAP's web-based transformer loading analysis capability, grounded in IEEE C57.91, gives transmission owners the engineering confidence to safely maximize transformer utilization before considering costly replacements or upgrades. By accurately modeling thermal behavior under real operating conditions, including ambient temperature, load history, aging effects, operators can identify true capacity margins that conservative static ratings often obscure. The result is a data-driven foundation for deferring capital expenditures, extending asset life, and making replacement decisions based on engineering evidence rather than precaution. ETAP 2026 transformed grid operation from a constraint-driven challenge into a data-driven, engineering-led opportunity. Engineering data lives everywhere. GIS systems, legacy analysis tools, BIM platforms, CAD environments. The challenge is always getting it into your model accurately, completely, without weeks of manual reentry. DataX in ETAP 2026 sets a new standard for interoperability. Starting with our own portfolio and expanding on the interface between Canico BT and ETAP, we now have a seamless conversion with automatic diagram generation and library mapping. Engineers can streamline low-voltage design, eliminate duplicate data entry, improve consistency from sizing and equipment evaluation to detailed engineering and system analysis, from low to high voltage systems. We have added native ERAX data exchange, which is an automatic conversion from ERAX to ETAP, with automatic single-line diagram generation matching the original layout, and a library mapping tool for protective devices. For engineers migrating from ERAX, this eliminates weeks of manual effort in a single operation. SKM Power Tools import has been enhanced and now supports versions 6 through 11, with improved diagram generation. And we now support Autodesk Revit 2025 and 2026. Excel Data Exchange now covers 22 new element types with universal mapping for full flexible import customization using Excel. SIM, the Common Information Model, now covers both SIM15 and SIM17 formats, with automatic GIS diagram creation from SIM-XML, device warehouse generation, incremental updates with component comparison, and automatic single-line diagram updates for modified areas. Wherever your data lives, ETAP 2026 brings it together into a single source of truth. The final frontier of the electrical digital twin is not design, it is operations. Taking that physics-based AI-powered model and connecting it live to the running power system. Automating decisions. Training operators before faults happen. Responding to disturbances in seconds, not hours. In ETAP 2026, we have advanced every layer of our operations portfolio. eSCADA has been enhanced with a new communication backbone, which improves managing very large systems, expanded protocol support, automatic energized and de-energized feeder coloring, zoom view links between HMI sections, and modernized web applications focused on surfacing critical information without cluttering the operator's view. ETAP Grid, our advanced distribution management system, now delivers enhanced fault location isolation and service restoration. With the ability to prioritize critical loads such as hospitals and municipalities, ensuring essential services are restored first. Switching optimization generates automatic optimal switching sequences and displays the step-by-step path to reach any user-defined target configuration. And eProtect now covers an expanded range of relay models, with advanced relay settings reporting for field technicians and a relay health KPI interface, providing full lifecycle visibility from settings management through real-time operations. Now, let's hear from Tanush to summarize this overview of ETAP 2026.
9 pillars of innovation, more than 50 new features and enhancements, over 23,000 new verified and validated library models, the most advanced arc flash, dynamics, renewables, and AI capabilities we've ever produced. But behind all of that, there is one idea, that the most powerful tool an electrical engineer can have is a model that truly reflects reality, not a drawing, not a point in time, a living, intelligent, continuously updated representation of their power system, from design through commissioning all the way to daily operations. This is what ETAP has built for 40 years. That is ETAP 2026, Continuous Energy Intelligence. Thank you.